Okay, to solve question 23, we are finding the area and the perimeter of this regular polygon. It is an octagon. So we're going to find the area and perimeter of this octagon. We actually did this exact example in the notes. So if you want to go back and take a look at it, it's also there. Now, what I've done here is I've drawn every radii. And remember, a radius of a polygon really is the distance from this center to a vertex. It's equivalent to the radius of the circle that could be circumscribed about this, which would be this distance of 11. Okay, and I've drawn them all. Okay, and if you notice what that does, that gives us 8 congruent triangles, one for each side. Now, in order to find this area, we need to find the apothem, and we also need to find the length of this side. Now, because this is an isosceles triangle, not only is this height the apothem, okay, but it's also an angle bisector, and it's a perpendicular bisector. So this would be x, and this would be x, and whatever this angle is for this particular right triangle, all we would have to do is divide this angle by 2. Okay, so what we need to do is we need to find this angle right here. Now these are 8 congruent triangles. If you were to add all 8 of these angles up, it would have to equal 360 because it does make a full circle. So what we would do is we would take 360 and we would divide it by 8, and we would get 45. Now, like I said, this altitude, which is also the apothem, bisects that angle. So to find the angle, the acute angle here in this right triangle, we would have to take this and divide by 2, so we would get an angle of 22.5 degrees. So if I were to extract that particular right triangle, here's what I have. Here is a measure, an angle measure of 22.5 degrees, and we have a hypotenuse of 11. With respect to that angle, this is the adjacent side, this is the opposite side, and this is the hypotenuse. We'll call this A for apothem, and we'll just call this X. So to find the apothem, we would take the cosine of 22.5 equals A adjacent out of 9 over the hypotenuse, which is 11. So to solve for A, we need to isolate. To get rid of the division by 11, we would multiply. So A equals 11 times the cosine of 22.5. Okay, so that's the apothem, and we'll leave it in terms of cosine. We don't want to round that decimal until the end. Okay, in order to find the perimeter, we have to find x. Okay, there are 2 per side. But to find x, we would use sine. The sine of 22.5 is equal to x over 11. X equals 11 sine 22.5. Alright, now that's x. Now again, not only is this an angle bisector, it's also a perpendicular bisector, so we have 2 of these x's per side, and we have 8 sides. So in order to find the perimeter, what we would have to do is take 16 times this length. So now we have the apothem and the perimeter. All we have to do is plug into our formula. We put the apothem in here first. Looks like we're going to run out of room. Okay, and here we have, we'll put bracket 16 times 11 times the sine of 22.5. Bracket here. And so the area is approximately 342.24 units squared. And the perimeter down here is approximately, so we also need to find that, the perimeter is approximately 67.35 units. And that is how you find the perimeter and the area of an equilateral, a regular octagon with a radius of 11.